Welcome to this amazing video where we are going to prove three identities, and based on these identities to practice, how do we apply them? Here are two important objective type questions. Such questions are challenging and are seen in many competitive exams. Students preparing for higher level competitive exams may benefit from these examples. I hope it makes sense. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. To understand maths and be on right on the top, you may send an email on globalmathinstitute@gmail.com. Our students are getting admission to the best universities, even with scholarship. Now let's begin with simple steps to prove the three identities. The question here is if A over B equals to C over D, then prove the following. See the procedure. We know A over B is equal to C over D. How about adding 1? It will not change the situation, correct? But when you add 1, you get A plus B over B equals to C plus D over D. So that is the first identity, right? So sums in the numerator can also work. Now, think about subtracting 1. So if I do A over B minus 1, that should also be equal to C over D minus 1. And that gives you A minus B over B equals to C minus D over D, right? So we have shown the second one. How simple it is, correct? This is known as componendo and dividendo. Now I'll show you what happens when I divide one equation by the other, right? So let's say this is my first identity, this one is the second identity. Now just divide the first one with the second one. So if you see that, like here, you see that? Then these denominators will cancel, and what you get is the third one, right? So we get the third identity, which is if A over B equals to C over D, then A plus B over A minus B equals to C plus D over C minus D. Is that clear to you? Perfect, right? Now we have a question for you. So we've kind of made it slightly difficult. We are writing P plus Q over P minus Q is 7 over 5. You have to find P over Q, kind of reversing, right? Okay, how are you going to solve this? Take a moment and remember, in case you really want to master higher level algebra or mathematics, join us. Send an email on globalmathinstitute@gmail.com. Great. So what we are given here is P plus Q over P minus Q is equal to 7 over 5. Now, let's apply this property of componendo and dividendo. That is to say, we'll add P minus Q, right? To the numerators, we have P plus Q plus P minus Q, and we are going to subtract P minus Q from P plus Q. And here we get 7 plus 5 over 7 minus 5. Does it make sense, right? So when you add this, Q's cancel in the numerator, we get 2P, and here the P's cancel, and we get 2Q equals 2. 7 plus 5 is 12, and 7 minus 5 is 2, which is 6. 2 and 2 cancel. So P over Q is 6, correct? So we get the answer 6. Option A. Does it make sense to you? It was extremely difficult, but since we know the property, we can apply it directly. Here is the last question for you. We are treating this as level 3. So apply the same property, right? So what are we going to do? We have square root of p plus square root of q, right? Add what is given in the denominator, which is square root of p minus square root of q, over from the same thing, subtract square root of p minus square root of q. And that should be equal to 4 plus 3 over 4 minus 3. Makes sense? Now you'll notice that in the numerator, it will be 2 square root p. Let's change things. 2 square root p over 2 square root q. Perfect. Equals to 4 plus 3 is 7. 4 minus 3 is 1. 2's cancel. So we have square root p over q as 7, right? So what is p over q? That will be 7 square, and that is 49. And therefore, we get option B as the right option. Do you understand? So see how beautifully we have applied these identities. We saw how do we prove them, and also how do we apply them to answer some very difficult questions. So these questions related to ratios and proportions can easily be solved using this technique. I hope it makes sense. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.